Hello friends, welcome to an exciting project. Today we are going to combine Arduino Uno with ultrasonic sensor, and we are going to take the output on the actuators like buzzer and LED. So this is a complete project including or involving sensors and actuators. Now what is a sensor? Sensor is something which senses. Like for an example, if you consider our body, we have light sensors, that is our eyes. Then we have sound sensors, that is our ears. Then we have touch sensors, that is our skin or hairs. So these are our sensors which we have in our body. And the tendency of sensors is to sense something and give input to the brain. Now here in this particular project, our brain is going to be Arduino Uno. So we are going to use ultrasonic sensor. As you can see on the screen, this is an ultrasonic sensor HC-SR04. Now this ultrasonic sensor has two main components: a trigger pin which is denoted as T and a receiver pin which is denoted as R. Now, as I had explained earlier also, an ultrasonic sensor releases ultrasonic waves which travel in the atmosphere and gets reflected from somewhere, from any of the surface, and comes back and are received by the receiver. Now the entire function of this sensor is to detect any object which is close by. It works on the principle like sonar. It releases some waves, and then when the waves are reflected back, it gives out signal. So as I am discussing about signal, let us see what is. So see, VCC is going to be the power source. Then trigger and echo are the two pins. Trigger stands for transmission and echo stands for receive. So trigger pin is going to trigger the sound wave into the atmosphere, and that sound wave is going to travel and get reflected from the surface, any given surface, and going to come back, and being when it is received by an echo, we will get a particular signal. So when to trigger the ultrasonic sensor, and when whenever we receive that particular wave, those both the readings are connected on pin number, digital pin numbers 9 and 10 of an Arduino. You can see from the circuit. Okay, now as you can see from the circuit, VCC, that is the power pin, is connected to the power source, that is the 5 volt. Then the ground pin is connected to the ground. So in that way we have powered on the sensor. Now trigger pin is connected to pin number 9 and echo pin is connected to pin number 10. So these four pins, VCC, trigger, echo and ground, are connected to the concerned pins on the Arduino, as you can see. Okay, now let us come to actuators. Now actuators are something which are going to react once we receive a particular signal. So in our body, let's say that uh, you are you are being bitten by a mosquito. So when a mosquito bites you, your skin gives a sensation of something is pricking in, which is received by the brain, and then brain gives an order to either fly away the mosquito, or then either you kill the mosquito with your hand. Now your hand raises up and then taps on your forearm, killing the mosquito. Now this entire process is a triggered process, and it is this particular order is given by the brain. Now this is what is called as actuation or actuator. So in our project also, our sensor is going to detect something, and then once it detects something, or once we receive a signal on pin number 9 and 10, Then what to do is we are going to play a buzzer and we are going to glow an LED. So buzzer and LED becomes my actuators and HC-SR04 becomes my sensor and Arduino becomes my brain. So HC-SR04 is going to be an input device, whereas buzzer and LED are going to be an output device. Now let us see the connections of buzzer and LED. So buzzer, it has a positive and negative terminal, so anode and cathode. So anode is connected to pin number 11 of Arduino, digital pin number 11, and cathode, that is the negative, is connected to ground. It's a simple circuit. Now LED, again LED has two connections, cathode and anode. So cathode is always connected to ground, which is the negative terminal. So as you can see, cathode is connected to ground and anode is connected to pin number 13 on digital pin number 13 on Arduino using a resistor. Now this is a 220 ohm resistor which I have used in the circuit. Okay, so I hope the circuit is clear. You can refer this particular circuit for your reference. Okay, I would also be giving you connections and circuits and the code in the description box, so you can refer it there also. Now let us see the code. What are we going to do with this particular project? Now let us see the code. Now code is quite simple, even though looks big, it is a simple code. Now first, we have declared 4 integers: trigger pin, echo pin, buzzer and LED pin. So we have given the numbers of the digital pins on which those particular pins are connected. Like for an example, trigger pin is on 9, echo pin is on 10, digital 9, digital 10. Buzzer is on 11 and LED is on 30. So I have declared my variables. Now let us define 3 more variables. Now first is duration, then second one is distance, and third one is safety distance. Okay, so we have defined 3 more variables: duration, distance and safety distance. Now what are we going to do with this? That I'll tell you later in the program. Now let us, in void setup, let us set up the pins. So you can see, to set up the pins we use the function pin mode. So pin mode, then trigger pin output. So this sets up that trigger pin, that is 9, is going to be my output pin. So trigger pin is my output pin. Echo pin is my input pin. Can you read it? So whatever we are going to, that is pin number, echo pin is on pin number 10. So pin number 10 is my input pin. So in ultrasonic sensor, something is going to be released on echo and it is going to be collected on trigger. So trigger and echo. Now buzzer pin, again it's an output pin, buzzer, and last one LED pin, that is pin number 30 is my output. So as I told you before and only, that buzzer and LEDs are going to be actuators, so they are always going to be an output pin. Now next I have used serial begin, and that is the baud width 9600 to see something on the serial monitor. Now let us go to void loop. Okay. Now void loop, digital write trigger pin low. So we have used the function digital write. So digital write trigger pin low. So let us take that we are going to make trigger pin as low and delay of milliseconds of 2 milliseconds. So we are going to make the trigger pin low and we are going to wait for 2 milliseconds. Next is digital write trigger pin high. So what are we going to do? We are going to trigger something from the trigger pin. So whatever is going to be triggered is from trigger pin, that is pin number 9. So that it will be high and it is going to wait for 10 microseconds and again make trigger pin low. So what is this done? We have triggered an ultrasonic wave for 10 microseconds. Okay. Now duration. Now we have declared a, remember we have declared a variable here, duration. Now let us see the formula for that particular variable. So duration is pulse in. Now pulse in is a function which is going to count the pulses in echo pin, and we are going to put that echo pin on high. So as you can see that echo pin returns the sound waves and sound waves travel time in microseconds. Now this is your duration. Second is distance. So next variable was distance here. So we are going to define distance. So distance is equals to whatever duration we get here multiplied by 0.034 by 2. Now 0.034 is speed of the sound. Basically it is speed of the sound in per second. Basically sound travels in meters per second. So this is, it is generally 3.4 meters per second. So that is how it is going to be. So 0.034 by 2. I hope it is clear for you. Okay. So it's a bit long program as compared to means as compared to other programs, but don't worry. So basically sound travels with 343 meters per second. So 343 meters per second, that is the speed of sound. Okay, so here we have written that duration. Now safety distance. Now the next is, if safety distance equal to distance, okay, so whatever distance we have measured here in this, okay, in the distance will be given to safety distance. Okay, now conditions: if safety distance less than equals to 5. So if safety distance is less than or equals to 5, then the function is digital write. Then put buzzer pin on high and LED pin on high. So digital write, buzzer pin high, digital write, LED pin high. So if safety distance is less than equals to 5, then buzzer and LED pins both on high, else both low. Can you see? And the last part is the serial print. So we are going to print on the screen the distance. So serial print distance, and in new line serial print the variable distance, means whatever distance we are measuring. So what is going to happen, that in this particular project, if any object comes in a distance of 5 centimeters or less than 5 centimeters, so we can see that buzzer and LED is going to means buzzer is going to beep and LED is going to glow. And if the distance is more than 5, then we will not see any change in buzzer or LED, and both will be low. So any object detected closer than 5 centimeters or 5 centimeters, we will get a buzzer on this. It's a very good project. Now let us see the working of this. You can find this code in the description box. I will give you the code there. Okay, now let us see the working of this particular project. So I'm just going to simulate this. Okay, so let us see. I'm going to click on the sensor. Now see, this is the range of the sensor. When I click on this particular zone shows us the range of the sensor, and this is the object. Now you can see the distance here in inches or centimeters. So that object is, when I take it away from the sensor, the distance increases. So this is the range. After that range it can't measure, so this is the maximum range. So 290 at 300 centimeters. See, so this particular sensor has a particular range, so it can read up till this. Now let us bring it closer. You can see the distance reducing. Now as we know, we have already coded it, that when the distance becomes less than 5, we will see some kind of light and buzzer. So less than 5 centimeters. So let us focus on that. I am going to bring object closer and closer. You pay attention to the buzzer in LED. So now see, still not buzzing. Now can you see that when I reached 3.7 centimeters, it has started buzzing. If I go out, see 8.5. If I come in again, getting that? So 5 or less than 5. You can see that light glowing and the buzzer buzzing as soon as I cross that 5 centimeter mark. So this is how it is going to detect any object which is close to it. Now this is the same kind of circuit which is used in our parking sensors. You hear a buzzer sound and you hear that some object is approaching from the back when you are taking a reverse. So that is the same kind of circuit and the same kind of working process which is seen in our cars or parking sensing of our cars. I hope that you have understood the particular project. So don't like to share, subscribe and like. Thanks for your time. Have a good day.